Hello everyone. After understanding the basic terminologies which we have seen in the first video, now we'll directly move on to what exactly your semester is trying to say by having those knowledge. In that we have seen the overview of network security is required by the users to communicate on the network. If a medium is insecure, then intruder may intercept, read or modify the transmitted data from the sender. So this is an overview. In that the major question what they'll ask is what is exactly a network security is and give the elements of network security along with the example. So in the net elements of network security, as you can see, we are having confidentiality, we have having authentication, and we have something called as integrity. Now we'll talk about what exactly a confidentiality is. As general, confidentiality means nothing but providing the security for the data. Whatever the data which is flowing on a network, we are going to provide the security when it is transmitting from sender to receiver. That is nothing but your confidentiality. Whatever the data or whatever the information we are sending from one user to another user, from sender to the receiver, whatever the data we are sharing, for that particular data, we are going to keep the data confidential. In the sense, secure, we are going to keep. Now we have something called as authenticity and integrity. What do you mean by authenticity? In general, remember in ATMs, if you go to ATM, you will place your ATM card. In the sense, you will insert. Then finally, it will ask you for your identification with respect to PIN. That is nothing but your authentication. In the sense, authenticity is nothing but verifying the user's identity. Verifying the user's identity. Best example is your ID card. Is nothing but your authenticity. Now, if we talk about integrity, if the sender sends the data and the receiver receives that particular data, and if no modification is done, that time we tell us integrity has been achieved. In the sense, no modification should be done during the transmission from sender to the receiver. That is nothing but your integrity. Very simple elements, only three elements of network security. One is confidentiality, authenticity, and integrity. Confidentiality, authenticity, once you write these particular words, you need to justify what exactly is that with respect to diagram. If you see here, this is an intruder, this is also an intruder. Here we have user 1, user 2. He is sending the same data. You can see user 1 is sharing the data to user 2. These information is catch hold by the intruder. In the sense, third party person knows that information. So he sends, hi, I am user 1. So this particular intruder is pretending like I am the user 1. In the same here also, if you see, this is with respect to the algorithms. In the sense, some key concepts have come into picture by adding into that. And finally, if this particular person tells like I am also a user 1, we can rectify it because this particular user 2 will be having this particular key. Based on this key, they are going to do certain algorithms and they are going to generate one text. Based on that, he will get to know like this particular person is fraud person. So this is a general overview of elements of network security. That's all these things you need to explain in that particular sentence, the same thing. Now coming on to threats to network security. So in the sense, how exactly, in the sense, who can attack the network? Like I am the attacker, on what ways the information can be attacked in the network security, that is done by four category classifications. First is Indian essence domain name server can also be hacked. Routing table poisoning can also be hacked. Packet mistreatments can happen. Denial of service can happen. So how all these can happen? We just have a look now. First thing, DNS hacking attack. What is DNS hacking attack? In that hacking attack, you can find multiple ways of attacking the IP addresses. So what are those four categories as you can see here? One is masquerading attack, domain hijacking attack, information leakage attack, information level attack. So these are nothing but your information or domain or master attacks which you are going to write. So how exactly, what exactly is it in general? How can I tell? In general, masquerading attack, if anyone tells, just you keep in mind like we have one sender, we have one receiver. Sender is there, receiver is there is one third party person is also there. So when sender sends the data to the receiver, but the receiver receives the data from the third party. In the sense, he will tell like, I am the user, I am the sender, I am the original sender. In the name of the sender, in the name of the sender, he will send the same data to you. In the sense, to the receiver. That is nothing but your masquerading. Masquerading is nothing but third party itself assuming like I am the sender. So that would be your masquerading attack. Now coming on to domain hijacking attack. Whenever user enters a domain name, domain address is nothing but your IP addresses. Whenever you will enter, you are going to enter in any particular website, you are going to attack that particular website. So that is name domain as a name subject. Domain is nothing but websites you are going to attack. Just remember that. Now, information leakage attack is nothing but what? Any attacker sends a query to all the hosts identified with IP addresses. For that IP address, we are going to attack. Information is getting leaked through the IP addresses. That is nothing but your information leakage attack. That is nothing but your hackathon. Hackers are going to attack your IP addresses. Now coming on to information level attack, as the name suggests, information from level by level we are going to attack. First level is nothing but they will attack with respect to your different names. Third level is with respect to your domain name, and they can attack by directly to the storage. In a sense, wherever exactly your data is stored, from there they are going to attack. So this entire thing with respect to domains, with respect to IP addresses, with respect to websites, with respect to resource services, wherever attack is happening, we call that attacks as domain name DNS attacks. Now coming on to routing table attack poisoning. What exactly is this? Here we will be talking about two types of attacks. One is link attack and one more is router attack. In the sense, routing table means what? We have routing table here from this particular router, from this particular node to with this particular what say link, it has been attacked. So that concept came into picture. This is nothing but modification with respect to routing table will be your first thing. Then two types of attacks are there. One is link attack and one more is router attack. Now if I talk about link attack always occurs when a hacker get the access for the links. In the sense, when you are sending the data from one node to the another node, if this particular link has been attacked, so obviously all the information will be leaked to the third party. Now the same thing for the router attack. How router attacks will happen? With respect to the nodes. In the sense, in between the nodes you will be having a router. If this particular router is attacked, all the linked nodes which are there, that information can also be taken care. So here you need to mention something called as distance vector protocol, which you have already seen in module 3. Now coming on, this is the overview for with respect to the routing poisoning, routing table poisoning. Now coming on to packet mistreatment attack. What is packet mistreatment attack? Here we have certain examples for that. How exactly encryption happens, what will happen, modification happens, replication, anything happen there, or what exactly happens, we are going to see. Packet mistreatment, as the name suggests, when you are sharing the data from sender to the receiver, there are packets or data moving from one node to the another node. That packets, how mistreatment has happened in the sense, if that packet get interrupted, what will happen? We are going to see the destination also receives the interrupted packet only. Modification, in the sense, as the name suggests, whatever the data you are sending from the sender to the receiver, that data has been modified. In the sense, they will take the original data and they will replace the duplicate data. That is nothing but your modification. Now replication comes into picture. In the sense, the receiver receives the data from original sender as well, and as well as from the third party. So that replication, in the sense, duplicates are happening with respect to replication. Now malicious misrouting of packets, in the sense, a hacker may attack a router and change its routing table, as we have seen in earlier, that is routing table poisoning. Now ping of death. What do you mean by this ping of death? Attacker may send a ping messages like, my IP address is dead, now don't share me any information to this particular receiver. So that also can happen with respect to ping death, miscellaneous misrouting of packet, replication, modification, interruption. That is nothing but your packet mistreatment attack. So once you understand what exactly packet mistreatment attack is, now we'll move on to DOS attack. That is nothing but your denial service. Now denial service is nothing but whatever the data you are sending from the sender to the receiver, the third party will send that with respect to sender's name. In the sense, he will tell like, I only sharing the data, I am the sender. I am not the third party, I am the original one. He will prove himself. That is nothing but denial of service. Denial of service is nothing but it is a type of security breach that prohibits a user from accessing normal provided services. In the sense, it may be delay with respect to money or delay with respect to time. So only denial of service. There are mainly two types. Very important denial of service because majorly many people ask this in last year also they have asked this. Single source and distributed, you need to tell. What do you mean by single source? Single source is nothing but an attacker sends a large number of packets to a targeted system to disable it. In a sense, this particular information is getting from this resource. I use this resource rather than using the original one. So single resource attack has happened there. Distributed in the sense from different IP addresses you are getting the data. That is nothing but target to this particular system and share these resources to this particular information. In the sense, this particular IP address. That is nothing but attacks. Very important elements of network security and attacks, treats of network securities. In that you need to mention four attacks. First attack is DNS hacking and DNS attack, and second is nothing but your packet mistreatment, and third is nothing but your denial of service, and fourth is nothing but your link attacks. In the sense, your routing table poisoning. Now we'll move on to very important topic, that is overview of security methods. Why overview of security methods have come into picture? Here majorly you will be having two types of techniques are there. Two techniques are there. One is cryptographic technique or authentication technique, and one more you will be having is substitution techniques. Substitution. Substitution technique and cryptographic techniques or authentication techniques. Verification techniques, cryptographic techniques, substitution. Cryptographic technique is also called as authentication technique. Substitution technique is also there. So in the substitution technique, you in the sense how exactly you are going to secure the data. We talked about security, right? How you are going to provide that. I said right, we have multiple algorithms, multiple methods are there, techniques are there. So in the today's class, we will be seeing what exactly these technical supports are. In the sense, methods are. In that we have security methods. In the sense, what is substitution technique? Substitution technique is nothing but we are majorly having two types here. One is Caesar cipher and play phrase cipher. In the sense, we would have already seen a number will be given alphabets. A is nothing but 1, B is nothing but 2. Like that, up to Z, if you go, you will give a number for words. So that is nothing but 26. So substitution method is these particular letters, English alphabets are substituted with respect to 1 or 2. There is certain algorithm, Caesar cipher is also there, where key will play important role, where 1 should be less than or equal to key, less than or equal to 26. So as of now, we'll not bother about what exactly substitution techniques are. We'll directly move on to the cryptographic techniques. What exactly these cryptographic techniques are? In that, what you are going to learn, which is a major important role plays, all those stuff you are going to learn in this particular cryptographic technique. Cryptography is the process of transforming a piece of information or message shared by two parties in some sort of code. In the sense, we are going to, as we already know, what is cryptography? Converting or the process of the study of encryption or decryption, both we call it as cryptography. So in the cryptography, you will find both encryption as well as decryption. So what encryption is nothing but what? From plain text you are going to convert to the ciphertext. Decryption from the ciphertext to the plain text. Now what exactly this is? As we have before learning certain algorithms, they will be having certain methods as well. In the sense, overview will be there. Certain terminologies which you need to know. We have message M. M is nothing but message, and the secret key is nothing but K. We are going to denote that, and exclusive or wherever you find this particular symbol, we call that is as exclusive or, and there is encryption formula which is we are going to carry it out. M exclusive R with respect to key, if we do, we will get a ciphertext. In the sense, ciphertext we are going to get here. So these ciphertext we need to again convert. Decryption has to be done. So decryption we are going to write M, again exclusive R on key, and again key if we apply on that particular encryption, you will get a message. So decryption. So cryptography is nothing but study about encryption and decryption. To do encryption, this is a simple encryption which is carried out, and we have decryption as well. So once you understand that, always remember encryption techniques which we have already seen: symmetric and asymmetric. In symmetric we are going to use secret key, and in asymmetric we are going to use pair of keys. Pair of keys in the sense public as well as private keys. Now if I talk about public key is nothing but which is available for all. Private key is nothing but which is available only between the senders as well as receivers. So that thing we are going to deal here. And the public key system is more powerful than the secret key systems and provide better security and message. And for that we have a diagram here. Do you need to mention what is the cryptography technique and as well as authentication techniques. So this is a diagram which says you have a server A here, server B here, and you can draw circles here with respect to, not exactly you need to draw, just remember any network you can draw it. Link encryption and end-to-end encryptions are there. This is with respect to cryptography, and we call it as something called as authentication technique. What are the authentications? First of all, what is authentication? Authentication is nothing but identity. How we are going to identify you are getting a message from the same person or not. So we are going to authenticate that. So for that we have a word called as message digest and digital signature. Authentication can be done by two ways. One is message digest and digital signature. This you are going to learn in coming slides or coming pages. What exactly message digest and digital signature is. Hash functions will come into picture. So we'll talk about secure key encryption protocol. In that secure key encryption protocol, we are going to discuss with respect to data encryption standards and advanced encryption standards. So why we came across this? In the sense, we data encryption, all these are block ciphers. We know what exactly block cipher is. In the sense, you are going to convert the block of data or block of message into a ciphertext block. So block by block, we have stream cipher as well as block cipher. Stream is nothing but bit by bit, block is nothing but group of bits. So this is also called as, you can see here, secret key encryption is also called as symmetric encryption or single key encryption. Symmetric encryption can be done in two algorithms. First is your DSA, DES, and one more is your AES. So these are the two proper protocols which follow the block cipher, which follow the symmetric encryption, which follow the single key. We have only single key, right? Which is used in both the sender and receiver, same keys we are going to use. So that thing is nothing but your with respect to symmetric encryption. So in detail we will be wondering what exactly DES and AES. Very important question with respect to DES and as well as AES. Don't skip this particular topic. Now we will be talking about your data encryption standard, that is nothing but your DES. So DES stands for, if any question is asked, explain DES. You need to write data encryption standard. First abbreviation will come into picture. After that you need to maintain certain blocks. For example, first thing is what is the block size. You can tell what is the plain text size as well. So for this block size you can tell it as 64 bits. 64 bits block. 64-bit blocks. As you can see, DES uses 64-bit blocks. So this is with respect to block size. Second thing what you are going to do, this is going to follow which structure? It is going to follow something called as crystal structure. So remember this, it is going to follow the crystal structure. As in the diagram, I'll tell you what exactly that is nothing but crystal structure it is going to follow. And you should write down how many rounds we are going to get the cipher, in the sense original data, at how many rounds we are going to get. At round number 16. At 16th round we are going to get the cipher text. What would be our key size? Our fourth thing is we need to maintain what is key size. So here the key size is 64. 64 bits. So make a note of this, what exactly you need to write in this. 64 bits. And we have something called fifth point value, we have something called as sub keys also. So how many sub keys will be there? One master key will be there. For that, how many number of sub keys will be there? So sub key size will also be 16 because original bit size is 64 and sub key size will be 16 bit. Number of sub keys, this is nothing but number of sub keys is 16. 16 sub keys will be there. So this would be your 16 sub keys. 16 sub keys. And what would be the size of that sub key? 6 is nothing but your sub key size. Sub key size equals to 48. So this would be your 48 bit sub key size. And how much data you are going to receive finally? Whatever that input data you have given, the ciphertext data will also be of size 64. So this would be your first write-up part with respect to DS. One write-up part is what exactly DS is, data encryption standard, and it is going to use block a ciphertext. Then what is the size of plain text you are going to write? Size of plain text is 64 bit. Which structure it is going to follow? Phaser structure. How many rounds you are going to get the ciphertext? At the 60th round, round number 16, 1 6, we are going to get the ciphertext. Then what is the key? Key size is nothing but 64 bits. How many number of sub keys will be there? 16. How many rounds are there? That much sub keys will be there. And what is the size of that sub key? Size of the sub key will be 48. Finally, what is the output you are going to generate? Once you give the input, output is ciphertext of the size 64. So that would be your write-up part. After that, directly you will come to the diagram. In the diagram, how exactly we need to write, how what is in this particular diagram is. See, listen here. Here you have something called as initial permutation. This would be one box which you are going to write. For that name you are going to give as initial permutation. Permutation is nothing but whatever the data you are going to send to that particular state, it is going to divide or it is going to alter the bits. Bit alteration will be happening in permutation. So if you see here, our input is what? 64. Plain text is our 64 bits. We are sending 64 bits to the permutation. It is going to divide into two halves. So 64 divided by 2 is nothing but 32. So that would be your left side and that would be your right side. So these are divided equally, 32, 32, dash dash you are going to do. Now what each round will contain now. Now I am going to talk about round 1 first. So round 1, inside this you will be having a function. So what exactly this function is? Why we require this function? I will tell you. But as of now, just remember we are going to use the round function. So in this function, it is going to take the right. At the right side, always remember, at the right side we are going to apply the function, not at the left side. At the right side, we are going to apply the function. So that function is XOR. You can see here, this is XOR. XOR with the left out part of the plain text. So plain text, right side we are going to apply the function. For applying this particular function, we are going to take the key. Key we are going to take. So how this key you got 56, that also having a separate diagram for that. So these 56 we are going to take the input with respect to function, in the sense algorithm which we are going to use, DS algorithm, that it is going to apply for the XOR operation. XOR operation will take the give the in output to the permutation inside the round 1 permutation, and these also it is going to take the permutation from the original one. These two are going to mix up and finally gives you the L2 R2 input. So L2 is nothing but left 2 and right 2 with the 32 bits only. So these two is nothing but for the second round we are going to give the input. For the first round, L1, R1. So like this, till how many rounds we are going to do, that is for 16th round. At the 16th round also same diagram only, no change here, same diagram it is going to accept. And finally permutation will give you the 64-bit cipher text. So this would be your cipher text. Always remember plain text is divided into two parts. One is L1 and R1. R1 we are going to feed to the function, and this function by using the key we are going to perform the algorithm and XOR is done, and that XOR input we are going to pass on to the round 1 permutation, and normal we are going to take if these two are matching or if these two are same, then we tell it as hypertext we have received correctly. If we don't receive, again rounds will keep on incrementing. So how this key got 56 now? Secret key, we already know secret key because this is a symmetric cryptography. So secret key will come into picture, which is of size 56. So the same 56 will be formed, and it is going to divide inside this particular box. In the sense we need to perform two operations. One is rotation operation and permutation operation. So in the rotation operation we are going to divide this 56 into 28. These data we are feeding to the permutation, and finally we are going to generate the 56 data. So that thing is happening with respect to how many keys we need to generate. 16 keys we need to generate, sub keys. So that sub keys we are going to feed for the functions at the top. So this is how, what exactly I told, the same thing has been written theoretically. You can see here initially before round 1 begins. Before this round 1 begins, we are going to divide the plain text into two equal halves, and message key, this 56 will be your 50 key size will be there, and separately shuffled. I said right, permuted in the sense separately shuffled. After each 64-bit message is broken down into the 232, that is Li and Ri respectively. At that time 56 also we are going to divide into two halves. So all 56 bits we are going to produce with a version of this on the round 1. So how you are going to define and determine L1 R1? Very important formula here. Li nothing but your left. Li is nothing but your left side. Left side will always be equal to Ri minus 1. That is Ri minus 1 in the sense, if you see here, this is L1, and here we are going to take Ri minus 1. So only Ri minus 1 formula has come into picture here. For that you are going to apply the function, that is exclusive R. This is the formula for that. Li minus 1 exclusive R f of Ri minus 1 comma ki. Now, what exactly internally we are doing in the function f4? In the function, what we are going to do, we are going to take the key. The key size is 56 bit, and we are going to choose 48 bits from the function. You can see here, from the function we are going to take the 56, and finally we are going to select only 48 bits from that particular function. Then 32 bits from this is expanded to 32 bits to 48, so that it can be combined to 48-bit key sizes. If you see here, this we are getting 56 from here, and it is reduced from 32 we received here, that we are expanded, and finally we got 48 bits. And function also partitions to 48 bits of ki, with each 6-bit chunks are there, and finally Ri minus 1 equals to Ri minus 1 exclusive ki. This is very simple. With respect to diagram is very much important, and this formula is important. If you understand formula along with the function, what is the function it is going to do, just if you read once, already you will get here 8 marks from here. Now, the similar way for the AES, Advanced Encryption Standards as well. In Advanced Encryption Standard, this is a block cipher. This is block cipher, and you are going to divide the plain text into blocks. So, since above we had divided the plain text into 64 blocks, here we are going to divide the plain text into 128. We are going to divide that into 128 bit blocks. Again we are going to divide. It can also be used with respect to keys like 128 or 192 or 256 bits. This is a key size. This is a plain text size. And what would be your rounds? The number of rounds in AES is nothing but 10 rounds. So 10 rounds will be your for AES. We have master key, right? So master key size will be 128, or it can also be 192, or it can be 256. So each round will be having one word called as substitute units. That will be there. In the sense, byte by byte blocks you need to convert, right? So byte by byte substitution of blocks will happen here. In a sense, if 64 now ciphertext has been converted, next 64 will be taken. So that substitution will happen here. And the cipher moves through a permutation standard to shift rows to mix columns. In the sense, whatever substitution is done with respect to blocks, we are going to mix that with respect to columns. And finally, 16 blocks of ciphertext which we are going to perform exclusive OR. So once you write this particular theory, what is there, what is key, how much bytes we are going to take. So here we will not get any formula. Directly we'll move on to the explanation. If you see here, initial permutation will be there. M0 to M15 are the messages, and this is a key secret key. We saw a secret key there we had 56, and here we are having 128. So these keys expansion will happen depending on the rounds. So that we are going to take keys we are going to take at exclusive or at the last part only we are going to take. There we are going to use functions in DS, but here we are not going to do functions. Substitution is going to perform all those steps. This is one of the standard, or this is very important standard with respect to DS. The DS we will be having certain advantages or disadvantages that we are going to convert, and we are claiming this AES. This round is like substitution unit. You need to talk about S is nothing but your substitution unit. Substitution unit is nothing but it is a byte by byte substitution of blocks will happen. Permutation state is nothing but it is a form of rows and columns. You're going to form rows and columns, right? For that we call it as permutation stage. 16 bits AES decryption algorithm will come into picture. That is 128 bits will come. That's all. That particular diagram at the end we are not going to perform any mixed column at round 10. Only permutation will happen here. Finally, you are going to generate the ciphertext. These K1, K2s are important. So always remember in CNS you need to draw perfect diagrams. Based on the diagrams only the evaluation will happen. So that is nothing but with respect to symmetric key encryption. Now we will be talking about asymmetric. Asymmetric, as I already know, asymmetric is nothing but two key pairs. In the sense, both sender and receivers will be having public key as well as private key, and receiver side also will be having public key as well as private key. To accomplish that particular asymmetric algorithm, we came across two protocols. One is RSA protocol and one more is Diffie-Hellman key exchange protocol. Now we talk about what exactly RSA protocols are and what is Diffie key encryption. If they directly ask about explain or describe public key encryption, at that time you need to explain RSA algorithm protocols and Diffie-Hellman key exchange protocols. If they ask specifically explain RSA, or if they give program with respect to problem with respect to RSA, you need to write Diffie-Hellman as well as these two protocols. Now will not waste time and will directly move on to what exactly this RSA protocols and Diffie-Hellman key protocols. So before moving, you know the basic concept, right? What is public key? Which is visible to all, in the sense which is shared to all the programs, all the users. But private key is nothing but which is shareable only to the authorized users only. That is nothing but with respect to public keys. That same thing has been explained with respect to example, like if A wishes to send the message to B encrypts the messages by using B's public key. In the same way, at receiver end, B decrypts the messages by using the private keys. So public key systems are slow speed as well as more complex computationality will come into picture with respect to algorithms. Now we'll talk about what is RSA. RSA algorithm. RSA algorithm, once you hear RSA algorithm, it's your duty to tell what is RSA first of all. RSA is nothing but revert, Shamir and Alderman. Revert is nothing but RIVERT. Revert and Shamir. You need to tell about what abbreviations of that. These are the people's name. Revert, Shamir and Alderman. So once you tell this, after that you need to tell like it is a RSA public key encryption and a signature scheme. This RSA algorithm is nothing but public key encryption which uses signatures here. So what exactly is this? It is a best practice. We are going to convert, or we are going to assume plain text M must be encrypted to the ciphertext C. So we need to tell about this abbreviation. M is nothing but your plain text and C is nothing but your ciphertext. There are mainly three phases. Directly moving on to the algorithm now. There are mainly three phases are there. First phase is key generation, second phase is encryption, and third phase is decryption. Now we talk about what exactly how we are going to generate the key now. Key, first thing is the same thing what you are going to see here, apply the same. First thing is you are going to choose the any two prime numbers. The prime numbers you can give either P or Q, depends on you, A, B, and we are going to compute N. N equals to A into B. After computing N, we need to fix two keys. Two keys, one is with respect to X and one more is with respect to Y. Now what is X, what is Y? X is nothing but it is a decryption key where x is equal to a minus 1 into b minus 1 are relatively prime. Now if I talk about what is a relative prime now, relative prime is nothing but we say two numbers are relative prime if their common factor is 1. If they have a common factor as 1, we tell it as it is a relative prime. Now we need to calculate y. Y is nothing but your decryption. So key decryption key you need to calculate. For that we have a formula xy mod a minus 1 b minus 1 equals to 1. Very simple. Not you need to not break that much head. Very simple. If you remember this, you are going to calculate the decryption key. Very important RS algorithm as well as DP element. So here only they'll ask the question. At this point you are going to discard whatever you have calculated. A and B you are going to not consider at all. So finally you are going to tell like public key equals to x comma n and private key equals to y comma n. So public key will resemble to encryption and private key will resemble to the decryption. So now we are going to compute encryption and decryption. Our key generation is done. In key generation you need to talk about only 6 points. First point is how you are going to we are going to choose the two prime numbers A and B and we are going to compute n. After that we are going to select x and y values. X would be your encryption key and y will be your decryption key. For x, how you are going to do? X and a minus 1 b minus 1 are relatively plain, you are going to tell, and y here we are going to compute the mod, that it should be equals to 1. Then finally you are going to discard a and b. After that finally you will tell like my public key and private keys are x comma n and y comma n. Now these two values we are going to use in encryption and decryption. First we'll talk about encryption. Encryption, both sender and receiver must know the value of n first of all. After that sender knows the value of x and only the receiver knows the value of x, whatever you have computed up. Because sender is nothing but your encryption, receiver is nothing but your decryption. So those people will know x and y values. After that finally this is a formula to calculate from plain text to the ciphertext. Here very simple reverse of that, m equals to c to the power of y mod n. So this is how many formulas you will get here? Only 5 formulas if you count. 1, 2, 3, 4, 5. 5 formulas if you write, your RS algorithm is done. So after that we have something called as Diffie-Hellman exchange protocol. In Diffie-Hellman exchange protocol, you just need to understand what exactly Diffie-Hellman exchange protocol is. Here we are going to take two users. Let me consider two users as user 1 and one more is user 2. For both the things, we are going to take three random numbers. In the sense, three random things. First thing is we are going to consider the prime number. We are going to take the prime number. First thing, prime number equals to a. Second thing is random integer we are going to take. And the third is nothing but we are going to generate g. We are going to generate g. This is x1. x1 is nothing but your random number. So these two, user 1 and user 2, will be having prime number. The prime number name is a. And here also you will get a. And random number is x1. And generator we call it as g and g. Both the cases will be same. For this both user 1 and user 2, now we need to generate the keys. So for that, if you see here, key generation algorithm, virtual private network, we are going to use normally this DP element key exchange protocol going to use the virtual private network. So in this key generation algorithm, if you see first user 1, this is for this particular user y1 equals to g to the power of x1 mod a. This would be your key. Y1 equals to this. For second user, how you are going to generate the same thing? Y2 equals to g to the power of x2 mod a. So that is for second user 1 and user 2. After that, for user 1, we are going to exchange the keys. Key exchange will happen at user 1 and user 2. So that exchanges, if you see, that exchange of keys will happen in the sense user 1 will get x2 and the user 2 will get x1. So the same thing, if you see here, k1 your user 1 then sends y2 to user 2. Now user 1 forms its key using the information its partner sends. Very simple formula. Only two formulas you need to remember. Rest all is same. K1 equals to y to the power of x1 mod a, because keys got exchanged for user 1. So y2 will come into picture here. And for user 2, y1 will come into picture. Only y1 and y2 x1 and x2 values will change. X1 and x2 will be same only y1 will go there and y2 will come here with respect to user 1 and user 2. Finally, you will tell like the two k1 and k2 are equal. The two users can now encrypt their messages, each using its own keys. So that is with respect to techniques for both the things. Just now we discussed about symmetric key as well as asymmetric key. Symmetric key is nothing but your secret key. For that we learned about our we just now we learned DES and AES, and now for asymmetric we learned about RSA and DP element. Both are having in AES and DS diagram is must ensure, and in RSA algorithm you need to write formulas. Formulas are very much important. In DP element very simple formulas are there. Only you need to understand is you are majorly having two users, user 1 and user 2. For user 1 also we are going to have three parameters. One is prime number. The prime number name we are going to give as A, and random number as x1, and generator as g1. In the same way for generator as g, in the same way for user 2 also, but only the key is x2 here. Random number we are going to give as x2. Now how we are going to generate the key? Y1 and y2. Y1 will be for user 1, y2 will be for user 2. Y1 equals to g to the power of x1 mod a, and y2 equals to g to the power of x2 mod a we are going to do. At the end we are going to shuffle the keys for user 1 and user 2, and finally we will tell that both are equal. Now we will talk about authentication. What do you mean by authentication? As we just saw, we are majorly authenticating with the two things. One is message content. If whatever the message user is sending or receiving, if the message content are same, we are going to verify that content. Second thing is whether we receive the message from the same sender or not. So two things we are going to do for authentication. One is with respect to message, and one more is with respect to the message sender, and one more is with respect to the message content. Now if we talk about message sender, we are going to authenticate through implementation of digital signatures. Very important, digital signatures we are authenticating the sender. Content we are going to authenticate by implementing hash functions and encryption of resulting message digest. Remember this, in authentication we are having two things. One is message content authentication is done, one more is sender of the message we are going to authenticate. Sender of message we are going to authenticate with respect to digital signature, and content we are going to authenticate with respect to hash functions. Now what exactly this hash function is? Fingerprint biometrics what we are going to give, that is nothing but your hash function. So we are going to check the results of hash function at both sender and receiver. Sender will generate one hash function, receiver will generate another hash function. If both the hash functions are same, then we tell it as we got received the data from perfect user only. So that if any message we are going to apply hash, we denote it as hash of imp. Then hash functions will follow. Obviously any protocol or function you are following, they will be having certain properties, right? These are the three properties for that, how we are going to calculate. So in this, if you are going to like, unlike of encryption algorithms, the authentication algorithm is not required to reversible. So in the encryption and decryption, just now we saw, right? From the receiver also we can do encryption or decryption. From the sender also we can do encryption and decryption. But in this, we are not going to follow irreversible. Reverse operation is not possible. Only encryption is done, means encryption algorithm only we are going to follow. No decryptions are done here. Message digest is h of m. It is a computational infeasible to find m. So finally we'll tell like both the hash functions are mixed, same in the sense we tell like these are been perfectly achieved. So whatever algorithm you are going to do, we will be having if we want to in depth, if we want to go what exactly message authentication is, we are going to implement in two ways. First way is nothing. First method is nothing, but in general I'll tell what exactly this paragraph is trying to say you. We have certain hash functions which we are going to implement. We have first method is going to tell like we are going to implement the hash function. Hash functions we are going to implement for what? For the message content. For the message content we are going to implement the hash functions to provide what? To provide the message digest. To provide the message digest we are going to implement the hash functions. Here encryption and as well as transmission over a network message digest is done. Received at the receiver side is also done. That computation diagram is there. If you see here, user 1 is sending a message and we are performing the hash, and this would be your encryption. A is nothing but encryption. Using key we are performing. So finally h of m we are going to generate, that is hash of m. That hash of m will move to the network, and in the receiver side that message hash function is there, right? That we are going to apply again hash function on that, and decryption algorithm we are going to apply with respect to the key, and finally compare will happen with a normal. If you see here, from there we are extracting here h to h, these two if they are compare equal means, then we will tell like authentication of message has been done. So this is one method how you can tell like message content whatever you have received is perfect. In the second method what will happen is, in the second method we are not going to implement any hash functions. We are only we are not going to do any encryptions or the encryption or of algorithm we are not going to do here. Here we are going to do only the hash function. Only the hash function will come into picture. No encryption is done here. Remember, in first method we are going to do encryption, but in the second method we are not going to do any encryption. Only hash function we are going to apply. So only message hash we are going to do h of m we will get, and finally at the receiver end we are going to take the hash of hash, and these two we are going to compare and we'll tell like whether message content has been generated successfully or not. Very simple. This also very important. Authentication, if they ask explain authentication, you need to talk about two methods, two things. One is message content and one more is message digest. In the sense, sender sends a message over a network. So message content can be accomplished with respect to hashing function, and a sender message sender can be accomplished with digital signatures. So these are the two things. So just now we saw how hash functions, properties of hash function, three properties are there. In that also we have two methods. Message authentication can be implemented in two methods. First method is by implementing hash methods and encryption algorithm, and then second method is nothing but only the hash method, no encryption algorithm is implemented. So that is with respect to authentication of algorithms. Now, next coming on to secure hash algorithm. SHA is nothing but your secure hash algorithm. It is one of the major part of digital signature. This is for sender message. Just now we saw message content, right? Now this is for sender message. Digital signature standard. SHA1. SHA1 is there. SHA121, 240, 512. There are multiple SHAs, but here we are going to discuss only the SHA1. SHA1 is only for 128 bits. So digital signature is nothing but as normal people, if we sign also we will check whether you have signed properly or not. In the same way, for digital signatures also, lot many algorithms has been done, and many what say implementations, many practical sessions has happened to digitally authorize them by using biometrics, by using your scanner, codes, barcodes, all the stuff will come into picture. So the first version of the standard takes message with a minimum length of 2 to the power of 24 and produces a 160-bit digest. Here, this algorithm uses 5 registers. Remember, 5 registers, that is R1 till R5, and maintain a state of 20 bytes will be there. And here the first step is a pad message with M, and with the length M, the message length is 4 to LM equals to 448 mod 512. These are the standard sizes which you need to remember. Padding messages, these are the keywords. Padded messages, if what, remember students, whatever the topic you are writing, first thing is keywords are important. Oh, what keyword I need to mention here, that you need to think before writing. So after padding, the second step is expanded with the bytes with the bit size 512, that is 1632 bits words. M0 till M15 will come into picture. So WI is nothing but your word. For that message MI will come into picture, and that message should lie between 0 and 15, and word I less than 3. These all are with respect to the matrices which are formed using the SH algorithm. So then at the eighth step, what would be our delta value? So the delta value will be resulting to round Fi, R5, Wi and Ci. So finally R5 equals to R4, very simple, you need to mention this. And very simple formula, standard formula for digest, that is Fi, A, comma B, comma C. Here integration as well as your union come into picture. What are the authentications and digital signatures are? XOR will be there. These are very simple. 1939. Well, going to the exam hall, please remember this formula and write the same thing. Authentication and digital signatures are there. A digital signature on message is required for authentication and identification of a right sender, whether whatever the data we are receiving, that has been done. These digital signature is used in which algorithm? RSA algorithm. Remember, in RSA algorithm we are going to do the digital signatures. The message is encrypted with the sender's private key. Thus the entire encryption message serves the digital signatures. At the receiver end, the receiver will do decryption and finally get the whatever RS algorithm you are going to do, the same thing you are going to perform it. Our final topic is nothing but your firewall. Firewall is nothing but whatever wall, in the sense you are going to use one software. For that particular software, one wall will come into picture. It is going to filter it out, in the sense whether whatever the data you are getting, it is getting from the exact website or not, whether any data you are going to change or not, any problem is happening or not, that would be your firewall. Firewall is a place between host of center certain network and outside the network. So only remember what is required, only that is sent to the window, others we are not sending into the window. The main objective is nothing but to monitor, and packet filtering comes into picture. Unknown sources you are firewalling. Firewall can also be used to control the data traffic. Software firewalls can be installed into, if you observe, you have a Windows firewalls are there, hardware firewalls are there, which are very much expensive. Filtering operation is happening. For better understanding, this is a system, your systems or servers, there you are going to apply the firewalls. Router, for that also you are going to apply the firewall, which need to be sent, which not to be sent from the internet. Whatever the data you are getting, that you are going to store in router. From the routers, filters will happen. If you apply the filters, that filtering packets will reach local area network, your LANs, and finally the data will be reached to the particular system. Here we are majorly having three methods. One is packet filtering will come into picture, firewall filters will come into picture, denial of service will come into picture. So these are the three methods. Packets filtering will happen, in the sense firewall filters those packets that passes through that, and firewalls also packets based on the sources will come into picture. Denial of service will also come into picture. So whatever the topic or whatever the subject it may be, or whatever the module you are going to study, don't leave one topic, also study it clearly. And module 4 is very dead easy. Only you need to learn about elements of network securities, you need to learn about attacks, and you need to learn about RSA algorithm, DES, AES, and DPLMN algorithm, SHAs, and finally firewalls. Only count of hand count fingers you can count. Only those topics are there. Don't leave this particular module. Very simple. All the best.
Thank you.